This is a discussion of analyzing S-curve graphics. We're going to graphically determine the inflection point of an S-shaped curve. This is useful in many scientific applications, such as finding the equivalence point of an acid-base titration or of an oxidation-reduction titration. We will be using the results of an acid-base titration for our discussion. Some functions graph out oddly. One of these anomalous types of graphs is called an S-curve because of its shape. Look at the shape of this titration curve. Initially, when the x values increase, there is an almost linear increase in the y values, in this case the pH. Then at some value of x, the function, as you can see, leaps up, swoops up, and after that brief but huge leap, it eases off again in slope. The midpoint of the leap, somewhere in here, is called the inflection point. It's the point where the curvature of the graph changes from positive, as you see here, to negative. Here it's kind of turning down. We call that a negative curvature. The inflection point is a critical point in most titrations, so it's important to find out, in this case, how many milliliters, what volume of base has been added at the inflection or equivalence point. This volume is used to find the molarity of an acid that's being titrated by this base. Often the second derivative of the function is used, but if you don't have access to calculus, you can find an approximation easily and simply using plane geometry. First thing you do is find the beginning and ending straight data lines. Here you see them top and bottom. And draw a line of best fit on top of these points, and then extend them out past the curves. For the bottom and the top, an approximation of the straight line extended. Then you locate the points at which the lines diverge from the curve, both top and bottom. Here's the top point, and there's the bottom. Next, you construct a perpendicular line to each of the extension lines at the divergent points. You can use a compass and straight edge, or you can just use a carpenter's tool that can give you a good right angle. There's from the top to the bottom line, and here's the bottom to the top line. You'll notice those lines are not parallel. Then you'll bisect both of these perpendicular lines, cut them in two. You can use a compass and straight edge or just a ruler, and draw a line that connects those bisecting points, as here. Finally, you look to find the point at which the bisecting line crosses the titration curve. That will be a very good approximation of the inflection point in this data. You can then use that volume you see here, dropping down about 25.9 milliliters. Use that volume in your calculations, for instance, of the molarity of the acid being titrated.